Hello, everyone. I'm Carolyn Donovan from Olympus. I'd like to welcome everyone to this webinar on Achieving Product Cost Efficiencies, Portable XRF Case Studies and Examples. We have with us today as presenters Todd Houlihan and Marcus Lake. Todd is the director of our International Mining Group and has over 12 years of XRF experience in the mining and mineral exploration fields. Marcus is the Global Accounts Manager for the International Mining Group and has been involved with XRF since 2007. This webinar is expected to last 45 minutes. The main presentation should be approximately 35 minutes, leaving 10 to 15 minutes for Todd and Marcus to field your questions. If you do have questions, please type them into the Q&A panel in the lower right portion of your screen. Do not type your questions into the chat panel, as we will not be monitoring chat for our attendee Q&A. A recorded version of this presentation, along with the Q&A, will be available on our website by next week. We will send you an email with a link when it is up. And now, without further ado, I'd like to turn the presentation over to Todd Houlihan.
Hello, everyone. It's a pleasure to be speaking with you, or at you, today. Thanks for tuning in. I'm Todd Houlihan. I'm in Boston at the moment. My colleague Marcus Lake is on the other line from Australia. You there, Marcus?
Hello from Australia. Yes, I am. Hello from Australia.
Okay. We proposed this webinar primarily for two reasons. The main reason was to demonstrate and openly illustrate a best practice approach to using portable XRF, using our customers' experience working in this field. The second was to reach out to our customers and other people interested in XRF and connect with them in a more efficient and cost-effective way. Hopefully, this will save us travelling to every exploration camp and head office around the world. In an effort to assure you that this is not just a crafty sales technique, almost all of the information you'll see today has been prepared by our customers and is completely independent of our company. This has driven my colleague Carolyn crazy because she believes there's far too much text on the slides for a webinar, and that you'll all get bored and annoyed with me because you'll be reading the slides in your head while I'm reading them to you, and it'll drive you crazy. If she turns out to be right, then I apologise in advance. I'm very sorry for that. However, all of you working in this field are intelligent people, and I firmly believe that by showing you slides today that have been written completely independently of us at Olympus Innovex, this webinar has far more credibility and integrity as a genuine attempt to share important information. We're really passionate about the benefits of portable XRF when it's used correctly. I've spent the last 12 years of my life doing nothing else, so I'd better be passionate about it. Portable XRF is not the answer for every project, and there can be pitfalls out for. But where a project can benefit from intelligent use of an analyzer, it can benefit in huge time and cost savings. It's these cost savings that we'll focus on in the first part of the presentation. Then we'll discuss best practice methods of use before a final comment on return on investment. We'll then open the floor for questions for 15 minutes if we haven't overrun the 30 minutes allocated to the first part. Firstly, I'd like to thank the individuals involved with our customer companies who prepared the PowerPoints that we'll use today. I've had to only take parts of each PowerPoint to demonstrate certain aspects of the agenda, but it should be possible to send you each a complete PowerPoint upon request and approval of the authors. So a big thanks to Darren Holden and Rebecca Richards from ABM Resources, Chris Ben and his team at Goldfields, Guy Franceschi and his team at Volta Resources, Mark Manley from Phoenix Copper, and Frank Santaguida and Terry Sarlo of First Quantum Minerals. These PowerPoints were prepared by our customers, not us, most presentation at scientific conferences. The Goldfields PowerPoint was prepared for the International Applied Geochemistry Symposium in Finland last year. The First Quantum Minerals PowerPoint was prepared for an XRF workshop held at GTK, the Geological Survey of Finland, in January 2011. Mark Manley of Phoenix Copper has been a leader in this field, and I've used slides from two PowerPoints he has prepared. One of his was prepared for a presentation I gave at the World Mining Congress in London in 2009, and the Volta slides that you see in here were also prepared for that conference. Mark gave a more recent presentation of his work at a workshop in Australia organised by the Australian Institute of Geosciences on the use of portable XRF in mineral exploration sampling in May last year. The ABM Resources PowerPoint was prepared simply because they're great people. We've had a great relationship with them, and when we repair something on how they're using their units, they oblige. Either that or Marcus must have some dirt on Darren Holden. Seriously though, our philosophy is to work very closely with our customers and establish long-term relationships. This is what we're all about, through good times and bad. If we're heading into uncertain times, as the markets might suggest, then I hope this PowerPoint demonstrates how some companies are saving their shareholders enormous amounts of time and money. So these are the XRF we supply our customers at present. On the left is the Handheld Delta series portable XRF, which is the main advantages include increased mobility. The XRF on the right is the X5000 series, which is generally used at an exploration camp or in a specific location and samples brought to it.
Few of you are probably familiar with this product. It's our portable XRD and only one of its type in the world. It was originally designed by NASA, and a version of it is on Mars right now, studying its mineralogy. A gentleman named Philip Sarrazin started in situ and was able to commercialize a version of his invention that made this product possible. Olympus Innovex distributed this product for a year before buying the company. So in addition to the chemistry provided by the XRFs, we now offer a mineralogical solution that is truly portable. I liken this product to 5 years ago when I first started working with portable XRFs. Not many people were using them, and some couldn't see the added value in this equipment. That has certainly changed.
This slide is to give you all a feeling for who our customers are and the commodity sectors in which they work. You all should be able to recognise a lot of these companies and organisations.
Our element range begins at magnesium, and the heaviest element we add to a standard element list is uranium. Not all of these elements are typically calibrated on an analyzer. Our experience has led us to include 34 elements that are typically required, but we can customise elements where required depending on spectral overlaps. For example, gold can be analysed by our XRFs, but not below 5 parts per million, and can produce false positives in the presence of zinc, tungsten, and arsenic, because it sits in a very crowded area of the spectrum. So these things all need to be considered.
The next section uses a lot of the summary slides of our customers' presentations, and we'll flip from one project to another just to demonstrate the scale of savings possible. Later in the webinar, we'll show you how these savings were achieved.
This is a very busy slide, but an important point is highlighted in red at the bottom. ABM Resources, a copper-gold explorer in Central Australia, have been using 2 XRFs for more than 2 years, primarily analysing reverse circulation drill cuttings. They have estimated a saving of 900,000 Australian dollars in this time simply by reducing the number of samples being sent to the laboratory. If you care to see an interview with ABM's Managing Director, Darren Holden, on this subject, and several other interviews with our customers, please see our YouTube channel.
Phoenix Copper are exploring in South Australia and partially utilise the XRF in this style on the end of a pole, linked via Bluetooth to a field computer running a mobile GIS. In this case, Discover Mobile for map info. We also connect to ArcPad if ArcGIS is the GIS that you use. The elemental data is then immediately transferred from the XRF into a mobile GIS in the field. This provides rapid mapping and visual representation of geochemistry to aid decision making. It also allows far better and seamless data management. Phoenix have the luxury of fine-grained, relatively dry soils and can place the instrument directly on the ground and obtain excellent quality data. We'll show some data that compares results taken in the field with the comparative laboratory data later. Phoenix Copper have found that depending on the sample grid spacing and the topography, hilly or flat terrain, that they can take between 150 and 250 XRF readings, which significantly 100 samples they can collect per day using conventional sample collection for later analysis at a laboratory. So what does this mean for them? Well, Phoenix have been using 2 of our XRFs and 1 from another XRF supplier, And Mark Manley estimates the reduction in laboratory costs over 3 years amounts to savings of approximately 2.7 million Australian dollars, as can be seen at the bottom of this slide. First Quantum Minerals have been using several of our XRFs at their Kevitsa operation in Finland for both exploration and grade control. In their presentation early last year at GTK, they haven't quantified the savings as the previous two cases, but found XRF analysis to be very reliable in variable weather conditions and have significantly reduced the number of samples they've been sending to the lab. The short testing time has enabled them to make rapid decisions not possible with longer turnaround times from laboratories. So the benefits of rapid decision making are difficult to quantify, and they're very project specific.
Goldfields have been using our instruments at many locations around the world, but this presentation was given at the International Applied Geochemistry Symposium held in Finland last year, and their use of XRF equipment is also primarily related to the decision-making capability provided by portable XRF, similar to First Quantum. The application of XRF for a project in Mali, West Africa, discussed in Chris Ben's presentation, is extremely innovative. Chris discusses his measurement of immobile elements, chromium, titanium, and zirconium, combined with use of templates using rock, outstanding geochemistry programs of the IO gas to distinguish between lithologies and fresh rock, weathered horizons and soils. The project ran laboratory samples side by side against a Delta handheld. Point 4 on this slide is also the pertinent point, stating that careful application of a field portable XRF can produce the same outcomes as lab data. Very useful, to quote Chris.
The next two slides are from the work Volta Resources did a few years ago in Burkina Faso, where they were focused on their large Kiaka project. At that time, Volta were testing a wide range of samples, including drill core, RC chips, auger, soil, and rock samples. They're running 2 units continuously on a nighttime 12-hour shift and a daytime 12-hour shift, and testing as many as 7,000 samples per month. In calculating all the factors pertinent to consider the return on investment, Guy Franceschi estimated that his total cost for each sample measured using the portable XRF equated to approximately 98 Canadian cents, or say $1 Canadian per sample. So each listener on this webinar needs to assess for him or herself whether this represents good value for their situation. Guy cited the potential benefits of having more analysis results, the possibility that real-time chemistry provides to reorient auger and drill programs quickly, and the potential savings associated with collaring holes quickly and saving unnecessary drilling dollars.
The previous section cuts straight to the heart of why to use XRF, because the return on investment can mean enormous dollar savings of time, aid decision-making, or in some cases produce the same outcomes as the lab. The next 2 sections will show how this is done. Fit for purpose is an important concept in life, as it is when working with portable XRF. To what purpose should the XRF be applied? How can it be used on my project to add value? The setting of aims and objectives for an XRF program usually define its success or otherwise, or at least at an early stage, the user owner should be thinking about what accuracy and precision is acceptable. Projects benefit from using XRFs both qualitatively, say for identifying relative anomalies in areas of high, medium, and low concentrations of a certain element, or associating certain elements for certain rock types, and also quantitatively, as a measure of absolute value of metals in content and samples. This section looks in a bit more detail at what XRFs are being used to do for these particular outcomes. Within ABM Resources' old pirate deposit, like Goldfields, they are also using it to help discriminate between different lithologies, and during drilling to help predict the end of hole and identify barren quartz. Their aim is to detect diorites in the oxide zone, where they are difficult to preserve in RC chips and diamond core. What is interesting for ABM is identifying if the numerous diorites and dolerites are geochemically distinct to allow differentiation between several sills or stocks within and across drill holes, areas and across the old pirate prospect. This slide details on the right the elements associated with different lithologies and also mineralisation pathfinders as ABM understands them today. This sort of detailed comparative geochemistry that provides indicative associations of different elements with gold that help understand the geological system in which they are working. Here, observing a unique calcium response, the XRF has enabled the definition of a particular diorite sill. Here, plotting titanium versus zirconium attempts to differentiate different diorites and dolerites. ABM's Buccaneer deposit may hold different keys, such as the presence of elevated silver, antimony, and bismuth around the gold ore zones. At Buccaneer, arsenic and iron have been used to help associate the different fracture phases within the geological system. However, in the western zone, geochemistry suggests an arsenic low where gold spikes. It's related to elevated molybdenum above 500 parts per million, and elevated bismuth and copper with antimony slightly elevated towards the base and below the gold mineralisation. So the portable XRF chemistry is being used in several ways by ABM.
First Quantum have also been using their portable XRF for several aspects of the Kevitsa operation. Initially, as they were doing initial stripping, the XRF was a frontline tool for controlling grade of rock material for use on construction roads. And exploration has used them for till analysis, soils, and outcrop. In controlling grade during initial ramp-up, nickel had to be below 500 parts per million to be used on mine site roads. Such was the speed of the stripping and need for rapid decision-making regarding placement of stripped material, the Delta Classic and the Omega became a frontline tool. Checks were carried out to understand the behaviour of the instrument on these rough, unprepared samples when compared with the laboratory assays of the same material. Here, a similar mean and median was found, the XRF reporting slightly above 400 parts per million nickel, where the laboratory showed just below 400 parts per million. It's interesting to see the spread of data is broader on the XRF, probably reflecting the non-homogeneous nature of the material being tested in this case. This demonstrates how a proportion of laboratory assays should still always accompany an XRF program as a suitable check mechanism on the accuracy of the XRF data generated. First Quantum's Kevitsa Exploration Department have been analysing grab samples and testing till samples to help guide base of till drilling programs. Rapidly analysing grab samples, mapping and reconnaissance quickly identifies samples with anomalous metal content and helps identify rock type. Magnesium, nickel and chromium is used to help identification of ultramafic rocks. It's allowing field time to be more focused on anomalous areas and helps target the samples that are potentially most interesting for laboratory analysis. The till sampling program has proved useful to prevent delay in following up anomalies and additional costs associated with remobilising drill rigs. Anomalies are identified when the rig is still at the drill site and decisions made immediately. This has saved time and money with respect to drilling budgets. Here is a plot of copper as measured in base of till samples analysed by the lab and a Delta Premium XRF. The anomalies clearly identified by the XRF on the right, the lab is on the left, albeit at slightly lower concentrations. This is normally the case. Portable XRFs can underestimate the true value due to the presence of organic material, moisture, particle size, and the non-homogeneous nature of field samples, but it's all relative. This expands on the previous example. Nickel data in red is the lab and the blue is the XRF. The XRF significantly underestimates the true value, but consistently. This allows the identification of relative anomalies, low, medium and high, aiding in targeting and allowing FQM to focus their efforts in particular areas and utilise their time more effectively. Again, these benefits are difficult to quantify, but particularly in colder climate, with short field seasons, maximising the value of the time in the field can allow companies to get a better understanding of their different approach faster and help prioritisation. That's prioritisation of areas within a tenement or licence, or prioritisation of fieldwork across different tenements.
We showed this slide earlier. Phoenix Copper was the first company in the world to purchase a system that directly transferred XRF data into their mapping system. We termed this system the Explorer package, and this method has now become standard across the industry. This example shows the amount of samples collected using traditional methods in 1 month period prior to Phoenix using a portable XRF. After a month of XRF analysis, they had far more data points from which to build their understanding of the copper concentration in the surface soil above their Spalding deposit. They contoured the copper concentrations in MapInfo and then overlaid the information onto the local geology map and used this to site a couple of drill holes. Here Phoenix demonstrates how they're using the unit to enable genuine rapid-fire targeting.
Okay, so XRF chemistry is used by different companies in different ways to tell them certain information about their project. However, there are certain constants that should form part of every good portable XRF program. This section discusses these aspects. They include an orientation survey using your samples upon receipt of a new analyzer, optimising the test time and other instrument settings such as tube filtration or beams. Consideration should always be given to the level of sample preparation, if any, is required to satisfy the objectives of using the XRF. How homogeneous is the sample and how representative is what you are testing? Obviously this is a sampling issue and a science in itself, but how does the XRF's factory calibration perform on the samples that you want to test? Are there any matrix effects, an important consideration for portable and laboratory XRF? Is some fine-tuning of the factory calibration required to achieve your objectives? What QA/QC will we do as part of the XRF program? Blanks, duplicates, standards. Knowing about the different modes and algorithms used can be important. And which elements are you going to focus on? This section will show some examples of where good methodology has allowed the XRF to achieve the objectives set of it.
These plots show part of Goldfield's XRF validation procedures. It involves comparison of the XRF with lab data. The top two slides, arsenic on the left and strontium on the right. Both graphs show the results of running certified reference material at certain intervals to monitor the stability and integrity of the data produced. ABM undertakes check samples at the start of every hole and about every 20 to 25 XRF readings taken. They use two geostat standards and also blanks to ensure there's been no cross-contamination on the front window of the instrument.
This slide shows the results of an initial orientation survey by Phoenix Copper to help them establish the best methodology of testing going forward. Left to right is one soil sample grid line. In red are the laboratory results of samples collected from these locations. In blue, the XRF results of a 30-second test at that location, and in black, above that, are the results of the XRF on 6 tests. This was an orientation exercise carried out by Phoenix Copper. What this data told them was that the XRF produced data that generally contoured in the same broad categories as the lab data. It showed them that 30-second reading times was sufficient for them to achieve the accuracy they deemed acceptable. This sort of orientation work is recommended for each XRF owner. Here is data from that line. What was key for Phoenix Copper here was not having the XRF produce exactly the same numbers as the laboratory, but that the anomaly is well represented by both 30 and 60-second tests when compared to the lab. This gave them the confidence and some hard data by which to base the decision to do only 30-second tests at each sample location. Phoenix even did some work to understand the effect of moisture on XRF results. Portable XRF's generally okay on samples up to 10% moisture. The presence of water within a sample will diffract X-rays emitted from the analyzer and not allow all of those fluorescent X-rays from the sample to return to the XRF's detector. In addition, the analyzer assumes parts per million or percent dry weight. So with water in a sample, the mass of the sample is increased, which dilutes the total concentration of the target element. This is clear in these slides, where the green graph reports lower values. However, fortunately for Phoenix copper, the anomaly remains defined. This is more orientation work carried out by Volta on the Kiaka project in Burkina Faso. The graph on the bottom left was Volta assessing performance of copper through different sample containers, plastic bags, paper lab satchels, and XRF sample cups. This so they could establish the optimum method going forward. Also displayed in the two slides on the right, understanding accuracy of the instrument's factory calibration and whether there's some consistent under or overestimation. In these cases, the factory calibration can be fine-tuned and brought into line with the lab data if required.
Again, we want to stress the importance of having good, preferably matrix-matched standards with which to use on a daily basis to validate your XRF data. You should treat your portable XRF program as you would any analytical program in the terms of QA/QC that you put in place.
So, in summing up, calculating the return on investment for certain projects is very project-specific. And it's not just about fewer samples sent to the lab, but it's also about the speed of identifying anomalies. It's about more targeted sampling to maximise your analytical budget. It's about more intensive sampling in anomalous areas, helping assessment of end of hole and more efficient drill rig mobilisation, short field season optimisation, faster prioritisation of your most prospective tenements and licences, used for logging lithologies, and for faster decision-making in pits and in underground scenarios. But the bottom line is, your return on investment will be maximised with a robust XRF testing methodology, good aims and objectives, and good QA/QC.
Okay, so we're going to open it up for some QA from the audience. Please remember to type your questions into the Q&A panel in the bottom.
Do we have any limestone-related experience? Yeah, we do have some limestone-related experience. At the end of this short session, you'll have our email addresses. If you could send an inquiry to my email address, I can send you some data from some limestone-related projects that we've done. Calcium, silicon, magnesium oxide, these sort of elements we can do successfully. The lighter elements produce much more accurate and precise data when the samples are fully prepared to a powder. So that's one important consideration if any limestone work you want to do relates to light elements. Accuracy for light elements is the next one. Again, very dependent on your aims and objectives. If you're seeking to get the most accurate data as to achieve, as close to the lab results as possible on light elements, then you really need to be looking at doing full sample preparation. Although we do have a lot of customers doing light element work on drill core and using it semi-quantitatively or to identify relative anomalies, high, medium and low. So it really, again, comes back to your aims and objectives and determining what accuracy is suitable for you to make the decisions that you believe can help your XRF program.
How do we compare to NIR? Todd, I have to let you answer that one.
Yeah,
I haven't seen any numbers yet.
XRF results with near-infrared analyzers. It's an interesting question. I probably have to get one of our couple of geologists, to get back to you on that. Aaron Bench or Andrew Summers might be able to give you a bit more of a feel with that for comparative analysis of near-infrared. Claudio, get in touch with us, we'll get someone to touch base with you on that. Dermot, are there any new attachments planned to help with XRF of core? Yeah, analysis of diamond core is the most challenging application of portable XRF, just due to the sampling issue associated with non-samples in drill core, that it can be veiny and spotty. It's all about averaging with diamond core, doing number of tests per metre of core that enables you to achieve the accuracy desired. So a lot of orientation work is necessary with diamond core to understand just how many readings per metre are required. There are other methods, such as we have had customers who collect the slurry, the core cutter slurry per metre, so that the sample is more homogeneous, and letting that material dry out overnight and testing the slurry retrieved from each metre of cutting the core. That's really the two main ways that we approach diamond core analysis.
Leah asked a question about what's the maximum moisture in the content sample. Hi Leah, it's very late at night there in Indonesia as well. Moisture, the trouble with moisture is, as we've highlighted in this example, is where you've got the moisture particles sitting, you've got your element of interest, so you're going to get a diluted assay. The trouble with moisture in samples is moisture is very rarely constant, so you can't generally do a linear correction. So Leah, we can obviously discuss this more when I see you guys in a couple of weeks' time.
But 10% generally is the rule of thumb, but it is a rule of thumb only. Okay, we've got a question on limits of detection. What are our limits of detection for certain elements? So I'm just opening a document to remind me of those. But with best case scenarios for detection limits for gold is about 5 grams per tonne, and obviously that's very high for gold exploration. However, some of the companies that are our biggest customers around the world are gold explorers, but they're generally not using gold in using the measurement of gold using their XRFs to give them the information they need. They're using it to log lithologies and looking at pathfinders such as copper, arsenic, antimony, bismuth, mercury, silver. Our silver detection limit is around the same number, 5 or 6 grams per tonne, and detection limits are around the same, 5 to 7 grams per tonne in the best case scenario. Maybe you want to increase those numbers by double when you start talking real world samples. Instrument companies have to report their detection limits in a clean silica matrix. So I hope that helps. I hope that helps. We can give you, Claudia, we can give you more information in detail if you require.
Well, XRF and XRD are two similar but different testing methods. With the XRF reports true values of what concentration certain element is, and the XRF obviously reports the mineralogy, so it matches the phase. So with the XRD, to quantify it needs to be put into quantifiable software. So I would assume...
And the reason... Yeah, and also the reason that the XRF, we suggest it underestimates, we're only suggesting it underestimates on samples that haven't undergone sample preparation. So that when you do full sample preparation on materials, the XRF doesn't generally underestimate. So the underestimation from XRF is generally because the samples haven't been prepared. With the XRD product, the samples do need to be put in a powder form, so you're probably not going to see the same underestimation with the XRD because the samples to be placed into the XRD do need to be crushed and ground and sieved using simple manual tools that take 5 minutes, but you're probably not going to see that same underestimation with XRD. It's good. There's a lot of... Define full sample prep. That's a good question. What's full sample preparation? Generally, when we calibrate our instruments in the factory, we calibrate them on powders that are less than 250 microns. So I would have to say that that's full sample preparation. But in our experience, especially for base metals, sometimes a crush to less than 2 millimeters is perfectly adequate to get you plus minus 10-15% relative accuracy. So I hope that answers your question, Ian. Peter was asking a pretty loaded question there, I think, regarding would accuracy of measurements and efficiency on drill cores be improved if it was semi-automated rather than fully manual? I think that probably would be. Peter? Accuracy, efficiency would definitely be improved.
Efficiency better, accuracy better if you had some way to pulp a certain amount of that sample of the drill core to sample.
But exactly. But we obviously we can help customers who do wish to look at semi-automated analysis of drill cores through some partner companies that we have.
Claudio asked, can XRF data be exported into TSG software? That's that infrared software, isn't it, Todd?
Yeah, the spectral geologist. I'm not sure about that, Claudio. These are really good questions. And Carolyn would probably say at the end of this how, but it's probably a good time to say that at the conclusion of this, we will answer all the questions that have been asked during this Q&A, and that will be sent out to you all. So we'll get an answer for you, Claudia, on that. Can XRF data be exported to TSG, the spectral geologist software? I'm not sure.
Dr. Malik asks, how frequent the calibration needs to be done for contaminated soil sample measurement? What we're suggesting in our presentation is the reason why all these companies are having such great success is that they've run a very robust QA/QC program. So some companies do every 20 samples, some companies do every 50 samples. The trick to it is you need to run these blanks, field duplicates, and matrix match standards in order to validate your data.
Yeah, sometimes you need to adjust the instrument's calibration and sometimes you don't. So going in blind on a contaminated site, such as going in blind on a greenfield exploration project, you may be initially just using the instrument in a qualitative form to identify relative anomalies, high, medium and low areas of contamination that allow you to focus your efforts elsewhere. And once you send a proportion of those samples to the laboratory and get the data back, then you can get a feeling for how the factory count works and back calculate. In some cases, environmental companies will back calculate the laboratory results based on the correlation that they've achieved on a proportion of the samples when sent to the laboratory. So that's actually my background, contaminated sites. I suppose there's another interesting question that Dermot is asking regarding water analysis. I've heard some people using XRF for water analysis. Have you any examples and how practical is it? Obviously, there might be safety issues if this happens. In theory, XRFs can measure water. However, typically the detection limits or the limits of detection of the analyzer at 5 grams per tonne have been above the water quality guidelines that have been set so that it doesn't have a lot of application. Now, there is application in wastewater and processed water applications, and we have used the soil mode for that in the past, but soil mode's calibrated on powders, and when you start introducing a different sample type, then the results may not be accurate. So if we do have a special setup with the X5000 for analysis of liquids and special bottles and special calibration that allow to do liquid analysis. We do wear metals in oil and these sorts of things. So and again, if we're wanting to do water, I'd suggest an orientation survey, get some samples of known concentrations, let's test them and have a look. rather prove the application before we commit to saying we can do it or not, Dermot.
Claudio asked about if there's, I think you're asking, do we have permission for this equipment in Chile? Yes, we do. Claudio, if you contact us, we can pass you to our distributors based in Santiago, and they'll be able to help you out with all of your local permissions for this equipment.
Yeah, Dermot's talking about some stuff that we're already doing, Dermot. This is stuff that's in the pipeline. Dermot's asking for a QA/QC module or aspect to the software accompanying the XRF to help users complete QC on data straight from the XRF. Yep, great minds think alike, Dermot. At the moment, we're just using the IOGAS software program externally to the analyzer to do some QA/QC on it, but we want to move towards having an onboard mechanism after every 20 or 25 samples, what you choose, up comes a prompt to say, test this particular standard now, and if the target elements are within a certain range, it's acceptable to continue on analysing the remainder of the samples. So it's in the pipeline, Dermot.
From Baker Kuhidria, what is the XRF accuracy for rare earths and what type of XRF is recommended? So the answer to that, the accuracy depends obviously on matrix effects. We do have a specific rare earth instrument. It's called a Delta 50. Baker, if you'd like to hear some more of that about this instrument, we're happy to talk to you offline. Second question is from Robin Belcher. What format is the output in? The output is in, it comes out in a CSV format.
I can add a bit to Baker. I can add a bit to Baker's question regarding rare earths. Rare earths are the most difficult elements to measure using XRF, so we do like to get some samples from a deposit to calibrate the instrument, tune it in to that. We did some work with RAM Resources and SRK in Greenland last year, and the results came out really well. So Baker, you send me an email about that, I can put you on to the guys who did that project, and you can liaise with them on that.
There's another question there from training UAE. Todd, you can look after that. There is a training session happening in the UAE.
Yep, I'll be in Dubai the 21st, 22nd, 23rd of this month at the MENA Mining Congress.
Melanie Cox, you can answer that, Todd.
With the Delta model, does it work with a separate test stand?
Yeah.
Yes. Yeah. Any instrument can be, any handheld instrument can be purchased with a workstation, and you can use it as a benchtop instrument effectively, and then only take it out into the field where that's necessary. Melanie.
Emma Brown asks about when will gold analysis be more precise. Emma, we'd like to know that too. We're working on it. It's a work in progress. At the moment, it's about 5 parts per million, obviously depending on other matrix effects.
We can send you some data, Emma, on work we've done on geostats, a lot of geostats standards ranging from 1 gram per tonne up to 250 grams per tonne. And you can get a real good feel for the accuracy we can deliver on those standards and the effects of elevated zinc and arsenic in samples producing false positives as well. Suzanne Colclough, could you outline some ballpark costs? There's 4 models of handheld instruments starting at around $30,000 and going up to $50,000 US dollars, and then the X5000's about 45 to 55,000 US dollars.
Robin says, is there choice of the output file? Not at the moment. It comes out in CSV.
Or unless you're using the Explorer system, Robin, where the data goes straight into your GIS directly. So you don't need to download any data from the analyzer at all. The data goes straight into your GIS program. So in that way, you've got a shape file, a SHB file DAT file for the Explorer setup. That's right, Marcus?
Correct. It comes out for the map info, you get tab files, and
tab
for
files,
ARC, for ArcPad, you get your shape files and SSX files.
We'll answer Rami's. I'll talk to Rami about his question of adding elements to the library when I'm down in Dubai. But normally, if you want to add elements to an analyzer, it needs to be returned to the factory unless it's had a calibration shot. Christabel, what guidelines have you got for detection limits of nickel in high iron soil matrix? I can't answer that question straight off the bat, Christabel, but Aaron, who I think you know really well, will definitely be able to give you more detailed information on that. Yeah, it's a good question, though. It raises what guidelines have you got for detection limits of nickel in a high iron soil matrix? So this introduces some important concepts for a lot of our other listeners with respect to, I'm hearing some pretty bad feedback there, but because nickel sits right next to iron in the energy spectrum, when you have a high iron peak, you can mask a very low nickel peak next to it, and so we see similar things with chromium or lead and arsenic and different elements. So these are just limitations of XRF and relate to our ability to deconvolve the peaks and whether your XRF company has good deconvolution in their algorithms. Noise? Oh, it's gone now.
Okay.
Sounds okay for me now?
Yeah, it's sort of okay.
Christabel, will you be updating the analog Bluetooth to a digital Bluetooth? We actually we had some development meetings over the last couple of weeks where Aaron was here in head office in Boston, where I am at the moment, talking through our Bluetooth and Explorer setup right now. So Aaron's working on that, Christabel. You got a good reason to send a few emails or meet up with Aaron. I think he's coming to Perth in the next week or so, I believe. This is a question from Emma Brown. Could internal fans be used so the handheld devices can be used in the field in hot conditions? That's a really good question. So because these instruments generate X-rays, they're effectively similar to a light bulb and can generate heat, and in hot climes can fall over and have difficulty. Again, some of the meetings we've had over here the last couple of weeks have been looking at what can be done for these really hot climates to keep our instruments from overheating, and we're looking at that, Emma, to improve that all the time. We do have the heat sink on top of the analyzer at the moment to try and dissipate as much heat as possible, but I'm not sure if internal fans are the answer, but I'll see if we can.
Okay, question from Suzanne. What about measuring low cobalt in nickel sulfides? Suzanne would have to know how low the cobalt is in order to answer that question. Damien Watson, has a portable XRF been used in measurement of heavy elements in desulfurized gypsum samples? We're interested in mercury, cobalt, titanium, cadmium, copper, nickel, zinc, beryllium, and a few others. There's been some gypsum work done, I know, on our larger XRD instrument for mineralogy. I don't know how much work has been done with the portable Handheld XRF, but again, we run a couple of apps labs. We run an apps lab in the United States in Boston, and we also run an applications lab here in Sydney. So we're more than happy to talk to you about running sample trials and running our machine against your samples.
I think we did some work on heavy metals in Chinese fertilizers at one stage. So I'll see if we can dig out that data. If Damien, you want to send an email to either of us asking for that information. Suzanne was also asking about low cobalt in nickel sulfides. Yeah, we've done special work with low cobalt in nickel laterites, where we got typically very high iron, and we have that similar problem of trying to resolve the peaks associated with high iron and very low cobalt. So I'd be pretty confident we can do Suzanne's application in low cobalt and nickel sulfides. But obviously, again, we'd like to do some applications work and do some science and test some samples and demonstrate we can achieve the objectives that are set by a customer. It's really important. Sanam, my friend from India, for gold ore testing, is accuracy better in dry ore or in aqua regia? How accurate are the results? Well, Sanam, we can send you some data we've generated using our instruments. Gold is a special animal when using XRF, as most people listening will know. Fire assay is the best method for testing gold, and when you send your samples to a laboratory for gold analysis, they are unlikely to use a laboratory XRF system to do that. So whenever we try to start applying portable XRF to gold analysis, there are inherent issues associated with it. So I would always think about what you're doing. So the Goldfields PowerPoint presentation, which we should be able to send to you with Chris Ben's approval, is very interesting. And most of the Goldfields instruments, and Marcus can elaborate, they're our biggest customer around the world, but they are not using gold. They're not measuring gold with the analyzer, even though Goldfields and Anglo Gold Ashanti and these companies are gold exploration companies and gold mining companies. They're typically using the other elements associated with gold to provide them information with which to operate their exploration projects more efficiently, but not testing gold directly.
Well, all of our major gold companies don't use gold. We add gold onto their analyzer just to so they've got gold. They don't even worry about the gold in their gold exploration. The people that are using gold are using it's more of an alloy application. They're using it to check doré bar and sort of higher grade gold concentrates,
nuggets and alluvial nuggets and that sort of thing.
Okay, so on behalf of Olympus, I'd like to thank Todd Houlihan and Marcus Lake for their participation in today's event. Thanks very much to all of the attendees for joining us. We hope the material presented was informative and useful. Like we said earlier, a recording of this webinar, along with the Q&A questions from both of the sessions today, will be available on our website by next week. Please feel free to check back, but we'll let you know when it's up there. So that's going to do it for today. And again, thanks to everyone for participating. We'll see you the next time.